Okay, now let's start. So how many of you were not here in the first class? Oh, okay, not bad. Okay, so in the first class, the only thing we talk about was we talk about how to time travel money. And we focused on how much money I'm going to have in the future. Okay, so in the first class, I said, okay, if you put money in the bank today, how much is going to be worth in 5 years, 10 years? Or I said, if you want to have a fixed amount of money in 10 years, how much money you should put in the bank today? So this is present value and future value. Of course, what is important here is the interest rate. Interest rate has all kinds of information in it. There's the inflation information. There is the reward for waiting information. You know, if you put your money in the bank today, it means you're giving up consumption today. So you want a reward from the bank, and bank gives you the interest rate for this. And two very important formulas, actually one formula in different forms is this one. So whatever you have today will grow by 1 plus R every period. So if you have $100 in the bank today with 10% interest rate, in 1 year it's going to grow by 1 plus 10%. So at the end of 1 year, you're going to have $110. In 2 years, it's going to be $121. Why? Because you have 110 at the end of first year, and 10% of 110 is 11. So on top of 110, you're going to get 11, so you're going to have $121. Okay, so this is basically what we did in the first class. So we wasted the remaining 35 minutes. Okay, so now let's focus on multiple cash flow part. The part we mentioned in the first part, we had one lump sum of money. You had one amount of money, and we traveled it, right? You put $100 in the bank. You ask your uncle for some money. So it was one pile of cash traveling. Now we're going to have multiple cash flows throughout time. And then we're going to time travel all those cash flows. The first thing we're going to do is, let's start with the example. Okay? Please read the example. Your auto dealer gives you, can somebody read it? Okay, so basically, you have two options, right? The auto dealer says, okay, the car is yours, just pay $15,500 now. But you say, okay, maybe not. Maybe I will pay it in 3 installments. So I'm going to pay $8,000 now, $4,000 in 1 year, and another $4,000 in the second year. And the discount rate is 8% in both cases. Which one looks like a better option to you? You don't know any finance. You sit there. You like the car. And for $15,500, probably you can buy even like a second-hand like Range Rover there. I know it's very expensive here. In the US, it's not. Okay. So which one would you prefer? Pay the money now, all the money now, or the second option? So how do you compare it? You're paying $15,500 now. How do you compare this to that one? Tell me the base. Even if you're wrong, it's going to help me. So yes.
If you pay the first option directly, you will lose this all of the money. But if you pay only $8,000, you will have $7,500, and this $500,000 cash will be more, how can I say, valuable in the future. Therefore, paying first of all the $8,000 is more useful.
So he has the business mind, of course, right? I wouldn't think of it if I were sitting at the auto dealer with no finance education. What else? But like, of course, you're completely right. But what else?
Another choice is I will choose the second choice. I will pay interest but if I give the money cash, I won't pay interest 15,000.
Okay, so when I'm making the decision now, right? So I'm interested in the value of these two options today, right? So can I say, oh, in this option I'm paying 15,500. In this option I'm paying 16. Can I do that? Can I do that? Can I do that? No. Why no? Is this $4,000 worth same with this $4,000 today? No, time value of money. No, we cannot say that. It's a no. So in the exam, whatever, please don't add cash flows in different times to each other. Because this $4,000 is different than this $4,000 because of time value of money. Their worth will change. So this was a no. The way you should think the way Efe just said. So you should think about the worth of all those cash flows. So what am I gonna do? I'm gonna do this. I already know the worth of this option in today's value. In today's value, I need to know how much these worth today. So what am I gonna do? I'm at time 0. So these are the future cash flows, right? So how do you remember how I calculate the present value of future cash flows? I know this. We already did it in the first class. So I'm going to calculate the present value of these future cash flows. So what am I going to do? This is already at time 0. I don't need to do anything to this, right? This is at time 0. This is at time 1. I need to bring it to time 0. How am I going to bring it to time 0? I have 4,000 as the future value, right? This is at time 1, it's in the future. And I know that interest rate is 8%. And what is T? How many periods I'm pushing it back? Just 1 period. It's 1. So this is, I don't know whether I have the answer here. Oh, I do. 37. Just keep it like this, okay? And then I need to do the same thing for the second installment. Can you see it? Okay. So I need to bring it to time 0 as well. So the future value is 4,000. The interest rate is 8%. How many periods I have now? 2. So I need to make this calculation. So if you do this, bless you, you have 8,000 initial payment. Then you have the present value of the first installment, which will be 3,703. Then you have the present value of the second installment, 3,429. That's why I said, is this 4,000 same with this 4,000? No, one is worth 3,703 today. The other one is worth 3,429. So if you add those numbers up, as you can see, you're not paying $16,000 to this guy. In 3 installments, you're paying 15,133. So which option is better? This one is better. You're paying less, actually. Okay? In what sense?
Böyle bir şey mümkün mü? Sonuçta 16.000 lira ödüyoruz.
Hocam bankaya lütfen 15.133 lira vereyim çünkü değeri bu dersen yani öyle bakmaz olur.
Eğer sen 5 yıl sonraki faiz borcunu kapatmak istersen bugünkü değeri bu kadar değil, daha az ödediği var.
That's true. That's a very good point, actually. So basically, in this example, we are assuming that interest rate is fixed at 8%. Maybe in the second year, interest rate will be something else, okay? So there are other realistic things that might affect your decision. But still, you have to make this calculation, okay? Because you are making this decision now, And you need to know, you need to be able to compare those two options in today's terms. Again, this $4,000 is not equal to this $4,000. You are interested in today's values, okay? So this option is better. Can it happen? Like normally, lump sum, giving lump sum amount is a better thing, right? They give you the discounts and everything because people need liquidity. But still, you have to be careful. Okay, so business people are way smarter than average people, so you shouldn't be fooled. Okay, it's not smart is not the right word. Kurnaz, it should be kurnaz. Kurnaz. Okay, let's look at this one. What is the present value of the following cash flow stream if the interest rate is 8%? What is the value of these today? And then it says, what is the value of the same cash flow stream at time 4? So at time 1, you have cash flow of 250. At time 2, you have cash flow of 100. At time 4, you have cash flow of 300. So again, I will give you a few minutes. 5 minutes. Again, you're going to have a few minutes, and then we're going to solve it together. Just write the construct the question, write down the equations. You don't have to calculate the numbers. Okay, one thing I strongly recommend to you in time value of money questions is draw a timeline. Okay, and don't feel like a primary school student. I learned it in the MBA class at Iowa. So the instructor said, draw a timeline, it helps a lot, okay? So draw a timeline. This is our timeline. So at time 0, we don't have anything. At time 1, you have the cash flow of 250. At time 2, you have the cash flow of 100. At time 3, you don't have anything. And at time 4, you have 300. Right? And interest rate is 8%. So the question asks me, what is the value of these cash flows at time 0? So here I have the multiple cash flows. The only thing I need to do is I'm going to use this formula, and I will bring all the cash flows to time 0. This formula. The first part says what is the present value of the following cash flow. Then it says what is the value of it at time 4. So at time 0, I need to bring everything to time 0. And I will need your help because I don't have my financial calculator with me. So what am I going to do? I will bring this 250 to time 0 first. And I'm going to use this one. 250 is the future value. I know the interest rates. I have the time period. So I have 250, 108 to the power what? 1. I have only one time period. So it's going to be equal to what? Thank you. Okay. Then I need to do the same thing for this one. So I have $100 as my future value. R is 8%. This time, how many periods do I have? 2. So what is the value of this? Siz kontrol edin yazdıklarımı. Okay. And the last one is this $300 at time 4. Let's bring it to time 0. What is the T?
4.
It's not 3, right? It's 4. Why I'm saying this? Because we asked something like this in the exam, and for some reason you were confused because we had a skipped time period. We don't have anything at time 3, so I don't have to worry about time. That's why I'm saying draw a timeline. So I have 1, 2, 3, 4 periods. I need to bring this $300 back for 4 periods. So it's going to be equal to? Okay. So I have those 3 cash flows. What do I need to do now? I'm interested in their value today. So I add them up, which will be equal to Nokta? Okay. So this is the present value of those cash flows. As you can see, now compared to first R, the only thing we did was we have multiple cash flows. The idea is same. Now the second part. It says, do you have any questions on this? For the second part, it says, what is the value of the same cash flow stream at time 4? There are two ways to do it. Tell me the quick way. This number? So first I'm going to show you the long way, and then I'm going to show you the short way. So the long way is looking at the same timeline, but this time I'm going to calculate the future value of all those cash flows. So let's use green. Okay. So this time, what am I going to do? At time 4, I have this $300, right? At time 4, I have $300. I don't need to do anything to that. Then I need to calculate the future value of this $100. So the value of it is 100 in year 2. I need to take it to the future, to time 4, using this formula. So I had $100 with 8% interest rate, and I'm taking it to the future now. For how many periods? 2. Bu da var mı sizde? What's the number? Huh? Okay. And you need to do the same thing for this 250. You need to bring 250 to time 4. So this 250 will be 108 to the power how much? 3, right? See, time periods changes. The cash is at time 1, but time 1 is not anywhere here. You need to have how many periods passes until you reach to the future. So it's going to be equal to, now what am I going to do? I'm going to add those numbers. And it will give me the future value, which is equal to 7 something, right? Huh?
730.
Is that true? Sort of. What is the number? Oh. So this is the long way. The short way is you calculated the value of those cash flow at time 0, right? So you have this lump sum amount of pile of cash you already calculated the value for. So you can take this to time 4 immediately. You don't have to do those mid steps. So what am I going to do? What am I going to do? I can bring this value to time 0 with one step. So I can say 537.7 is the present value with 8% interest rate. I can take it to time 0 to time 4, and it will also be equal to 730. One step. Right? This is the present value. I'm interested in its future value. This is the value. Any questions on this? You can calculate the value of these at time 3 as well. If you're at time 3, then you're going to calculate the future values for those 2 cash flows. And you're going to calculate the present value of this 4th cash flow. And you can bring everything to time 3 as well. So you're just time traveling money, basically. Okay. Now let's go into more complicated stuff. We're dealing with multiple cash flows. The first thing we will talk about is the perpetuities. What's a perpetuity? That's something very interesting, actually. A perpetuity is an infinite sequence of cash flows, which are fixed. It's infinite. That's why it's interesting. So for instance, a company can say, buy this asset from me and I will pay you $1 every year forever. It's a perpetuity. Is it realistic? Is it used in real world? Yes. British government actually issued consoles 100 or 200 years ago, if I remember correctly, and they were in the form of perpetuities. Does it make sense? Yes. Why? Corporations can live forever. If a corporation can live forever, a corporation can make infinite amount of payments as well. Our lives are finite, but I can just think it as you can leave that asset to your son or daughter, and they can leave those to their son, daughter, whatever. So your family might have infinite sequence of cash flows. Okay, so that can happen actually. I know it doesn't sound realistic. It's used in real world. Another thing is preferred stock value is calculated as a perpetuity. Preferred stocks. And in the common stock chapter, you will also see we're going to assume that the payments, the dividend payments can go on forever because corporations live forever. How do we calculate the present value of a perpetuity? Things are changing a little bit. It's going to be equal to payment over R. So payment, these are periodic payments. They have equal amount of payments. Payments doesn't change forever. And R is your required return on your investment or the interest rate. If you're interested in the derivation of the formula, it's here. I'm not going to go over it. If you have difficulty understanding, then you can ask me. But let's look at this question. Let's read the first part. CHS Inc.'s preferred stock promises a $2 dividend that doesn't change year to year. Estimate its price if investors require a 9% return. So this is a perpetuity because they have fixed payments. And this is a preferred stock. That's why we should know that it's a forever payment. So $2 is your periodic payment. 9% is your interest rate. So the value of this stock should be 22.22. So now we are not using these because T is kind of unnecessary now. We're talking about infinity. Another question is, which is similar, a similar thing, required rate of return. So it says, if it currently trades at 25.24, what is the implied required rate of return? So it says you calculate the price of it, having this 9% interest in your mind, and you said the price should be $22.22. But its current price is $25. So is this overvalued or undervalued according to our calculations? This is the market price. This is the price you estimated. Huh? It's overvalued. It's overvalued. It's okay. What is overvalued or undervalued? Its value is $22, but the market overvalues it at 25. Its worth is 22. Its market price is 25, so it's overvalued. Would you buy an overvalued asset? Does it make sense? No, its worth is $22. If you're paying 25, you're not making a very good investment. So when you calculate the price in your estimations, you said my required rate of return is 9%. So if the price is 25, then what do you expect from the implied rate of return? Should it be higher than 9%, lower than 9%? Just think. Huh? Let me reword it and you will see it immediately. If you buy an overvalued asset, would the implied return be higher or less than your required return? Less, right? You had 9% return in your mind, according to that, the price should be 22, but since its price is 25, probably its implied return will be less than 9%. And let's see it. So you know that you're going to get $2 fixed payments from this investment, and its market price is 25. In that case, what's going to happen to R? R will be equal to 8%. As you just said, since this is an overvalued asset, the implied rate of return is 8%, which is less than 9% your required rate of return, because you're overpaying it. Once you pay more for an asset, then your return will be less, of course, right? So perpetuity idea is here. Present value is equal to payment over R. Any questions? Okay. Here, this is an easy question, but I'm going to pay attention to something very important here, and we will use the same thing in annuity, which is the next thing. So please try to pay attention. In order to create an endowment which pays $185,000 per year forever, so every year you're going to get $185,000 from this fund, how much money must be set aside today if the rate of interest is 8%? So interest rate is 8%, and every year I want to get $185,000. So what is the present value? I'm going to use this formula, right? That part is easy. So I'm going to get $185,000 every year forever with 8% interest rate. I should put $2.3 million aside. So the fund will never end if you put that amount of money in your account with 8% interest rate. This is kind of a tricky thing. Now we will have delayed payments, delayed cash flow. So what if, the question is the same, what is the value of an endowment today which will pay you $185,000 every year, but you're going to get the first money, $185,000, at year 3. So in the first part, for this question, the structure was like this. So every year you get $185,000. And you calculated the value of all these cash flows, infinite amount of cash flows, and you said it's worth $2.3 million. This was part A. Part B says, okay, you will still have this endowment, but suppose that you're going to withdraw money the first time in year 3. Then what is the value of this perpetuity of this endowment today? So what am I going to do now? The first step is the same. I'm going to calculate the value of this endowment, keeping in mind that its value, the first installment happens in year 3. Now I have to be very careful. So wake up. I have to be very careful here. According to the formula, there is a 1-year delay. What does it mean? If your first payment is at time 3, then this formula will give you the value of this perpetuity at time 2. So you're here, and this formula will give you the value of all the future cash flows ahead of you. Same here, okay? So in the first part, you got the first endowment at time 1. So the formula gave you the value of all those $185,000 forever at time 0. So the formula is the same. I just need to be careful about where I am in the timeline. So I'm going to use the same formula. I have one formula for perpetuity. I'm going to use the same formula, and it will give me the same thing. So the value of this perpetuity will be $185,000 over the interest rate, which will be equal to the same thing because I'm using the same numbers. So the value of this fund will be $2.3 million, but this time it's going to be worth $2.3 million at time 2. So I cannot stop here. I'm interested in the value of this endowment at time 0. So I'm going to take it to time 0 using our basic present value formula. I think I have it here, so let me not write. Okay. So this time, I'm going to treat this. I already calculated the value of all those cash flows at time 2. So now I'm done with the infinity part, right? I calculated the infinite amount of cash flow value at time 2. Now I can take this as future value with 8% interest rate and 2 periods. I can bring it back to time 0. So now its value will be $1.9 million. Let me repeat it one more time. When you have delayed cash flows, I need to be careful about the formulas and where I am in the time. That's why I say draw a timeline. Because when you have it like this, you see it clearly. Your first installment is at time 3. So the formula will give you the value of all those installments from time 3 to infinity when you're at time 2. So I'm at time 2, I'm looking ahead in the future, and the value of those all those installments will be equal to $2.3 million at time 2. Now I'm taking it 2 years back. And since I have this number, I can time travel this amount. I can take it as a lump sum and bring it to time 0. Any questions here? No? Okay. Let me introduce you annuity as well, and then next week we're going to continue. So in perpetuity we have fixed cash flows for an infinite amount of time. For annuity, we will have fixed cash flows that happens for a finite amount of time. So it's basically, think about mortgages. Okay, it's an annuity, and people use this all the time in their real life. So I think I lost you already. So let's just stop here. And next Tuesday, you will have the practice and also the quiz, and you will have all the time you need for the quiz. And the next Friday, we will start at 8:40 again.